Since that last one was so short, I'll go on and just wind this up. I was reviewing it though, and I noticed a couple of couple of errors in there myself. So again, be careful, double check, and I probably need a director or a technical advisor to be sure I stay right on the line here. Let's see. Okay, so we have 10 terms here for chapter 5. Let's look at what we have here. So we have something's loading up there. So term, coefficient, monomial, binomial, trinomial, polynomials, degree of a term, distributive, FOIL, and degree of a polynomial. All right. So for number 1, a what is a number or a product of numbers and variables raised to a power? I believe that's a term. Now I've defined terms as a series of expressions, the items that are separated by either a plus or a minus, those are the terms. The what method may be used when multiplying two binomials. Okay. This is a special method of multiplication that we call the FOIL, where we do the first, the outers, the inners, and the last. A polynomial with exactly 3 terms is called a trinomial. The what is the greatest degree of any term of the polynomial? That is the degree of a term. And that may not be it. Let's look here, because I don't know, it could be this one too. Here, I'll have to study that a little bit here. Okay, so it could be one of these. We'll have to see if the other one fits somewhere. A polynomial with exactly 2 terms, that one's easy, that's a binomial. The what of a term is its numerical factor. Well, we said that was the coefficient. The what is the sum of the exponents on the variable in the terms. Now that is the degree of the term. So this earlier one was the degree of the polynomial. And we're going to review that here too, and when we get to see an example. A polynomial with exactly 1 term is called, one having the prefix being mono, monomial. Monomials, binomials, and trinomials are all examples of polynomials. The what property is used to multiply this? Well, the distributive property. Okay. That's why it's always nice to have an example to back up your definition. Okay, I think we have to go to the next page. There we go. Highlights. All right. Lots of things to look at here. So, in reviewing, we have a to the nth power means that you're going to take the base a and multiply it by itself depending on what number n represents. So if you have a base 3 raised to the second power, that's the exponent. That means you're going to multiply 3 times 3 twice to get 9. And that is true for all of these. Now, when there's a negative included in the base, if the exponent is an odd number, such as 3, 5, 7, and so on, your final answer will be a negative. So if the exponent is a odd number, then the answer will be negative if there's a negative included in the base. If the exponent is an even power, 2, 4, 6, 8, and you're raising a negative base to that even power, the answer will be positive. That's the way you could check it. Now, in a sense, what it's saying is this is written 3 times. So negative times negative gives you a positive. A positive times negative gives you the negative. And keep in mind, when we're raising a fraction to a power, the numerator and denominator, of course, are raised to those powers. So here are some of the rules, product rules. If your bases are the same, you just add your exponents. If your bases, if your base is being raised to a power, that is something outside the parenthesis, you multiply exponents. This is the power rule. Notice the difference. Here there's no parentheses. Here we're raising a power to a power. All right, the product rule, remember, there's a exponent of 1 there, an exponent of 1 there. When you multiply 1 times n, you get n. 1 times n, you get n there. And it applies here as well. Now the quotient rule states, let's raise this up a little bit, and particularly if the n is smaller than the m, as we cross this division bar, the sign of the exponent changes and becomes a negative, and we just subtract them. So if in multiplication we add, in division we would subtract. And they give examples for all of these over here. Zero exponent. Anything raised to the 0 power is 1. Now there are times when you have a little challenge there. Let me show you that. For instance, if you had a negative 5 to the 0 power, the 5 would be a 1, but then we apply the negative. Now if we had a negative 5 in parentheses to the 0 power, now the negative sign is included in our base. That would equal a 1. So this is kind of a tricky case. You have to be careful of that. All right, let's go on. What is a term? Well, as we mentioned in the definition above, is a number or a product of a number and variables raised to powers. And when you have a string of terms like 3x squared plus 2x plus 5, then the terms are separated by either a plus or a minus. So these would be your terms. This would be a trinomial, as they illustrate down here, but we're getting ahead. So each of these are terms because internally within the term there are no pluses and minuses. Multiplication is okay because they say product of numbers here. Now in a term we have a numerical coefficient, which is the number part that precedes the variable. And here the term is 7x squared, but the coefficient is just the 7. Here our term is y, but in front of every y there is a 1 that we don't write, so its coefficient would be 1. And the same applies here. There's no 1 there, but there is a negative 1. That's the coefficient. And a polynomial is a finite sum of terms in which all variables have exponents that are non-negative integers and no variables appear in the denominator. And this is like the formal definition, because sometimes even the authors of our textbook will casually call something a polynomial, and they'll say it'll be 3x squared plus 2 over x. Now they'll call that a polynomial, but by definition it isn't officially a polynomial because there is an exponent in the denominator. And notice, if this were a negative 2 up here, that would also make it not a polynomial, because theoretically this should be down in the denominator. Okay, we won't go there right now, but just to illustrate that. So here's one term, here are two terms, and here are three terms, and the appropriate name by it. All right, let's go down a little bit more. Now, we also have been introducing and reviewing the word function. The function notation is to have a capital letter, or it could be a lowercase letter, and then we say the function of x here. P, the function of x, and the x is some variable that they may want you to use, as is illustrated over here. So they're saying the function of p here, I guess, and there is an x, and then they define it. They're saying that x value is going to be a negative 2. So you can think of it as a x value of negative 2, and here you have your function of p, and you want to know if x is a negative 2, what will this become? Well, you replace wherever there's an x, carefully watching the signs, with a negative 2, and here it comes out as a negative 28. And that's how we do it. So let's take a look at this word degree of a term. So as we look at the degree of the term, it's the sum of the exponents on the variables in the term. So the sum of the exponents on the variables in the term. So here the variable is x, the exponent is 3, so the degree is 3. Now here there is no variable, but you might think of it as 3 x to the 0 power, and the 0 power is 1. X to the 0 power is 1, so 3 times 1. So in a sense, the degree is 0. So where do we get the 0 from? Well, we're imagining that it's x to the 0, although it's not written there. That's why we say just the 3 by itself, its degree is 0. Now in this case, we see a to the second, a to the second, c to the first. So we add these, this is just one term. We add these 3 up and get a 5. So the degree of this term is 5. So that would determine the degree of a term. Now when you're doing a degree of a polynomial, it's the greatest degree of any term. So I always suggest you look at it, you say, what's the degree of this? Well, 2. What's the degree of this? 1. What's the degree of this? 0. And of these 3 terms, which one is the highest? Well, the 2. So that's where you get the 2 from. And here, this is going to be a 1, this is going to be a 5, and this is going to be a 0. In this trinomial, what is the highest degree of any one term? 5. That will be your degree of that expression, that polynomial. Okay? Now what students sometimes do is add them all up and get 6. Well, that would be incorrect. So don't do that. Watch this carefully and commit it to memory. And as you did your practice, hopefully that's what you were doing as you were developing your mastery. Okay, now some of these are pretty straightforward. When we are adding polynomials, and if you watch some of my other videos, take the like terms, take away the parentheses, and just put the like terms under each one. And then the parentheses are gone. And you just physically add them up then, and you get this. So if it's a plus between parentheses, just take away the parentheses, line the like terms up in like term columns, and add them. And sometimes it's sort of subtracting because they may be opposite signs. Now, when you have a subtraction problem, here the strategy would be to take away the parentheses from this one. But when you take away the parentheses from this one, because it's subtraction, you have to reverse all the signs. So this one will become positive, which they show here. This becomes negative. This becomes positive. And again, put them in like term columns. Or if you feel comfortable, you can add them up horizontally. Now notice when you are adding and subtracting, the variable part never changes. Okay? Never changes when you are adding or subtracting. And then we had multiplication, where here we're multiplying a binomial by a trinomial. You could do it this way, but you could also set it up vertically and then do long multiplication, getting like term columns and then adding them up. We had illustrated that earlier. Now here they're introducing the FOIL, which I'm assuming you already know. And then they're also introducing squaring a binomial, where we take the first term, square it, multiply these two terms together, double it, take this last term, square it, and you get this. When we do this, we get what is called a perfect square trinomial. That if you recognize that, it factors later into a binomial squared. Here it's exactly the same except the middle sign is negative here. Here it was positive, here it's negative. Otherwise, exactly the same. These are what we refer to as special products. Take the first term, square it. Multiply these two terms together, double it. Square the last term. This is a perfect square trinomial that later can be factored into that. All right, this other one is another famous special product where we're multiplying the sum and differences of two terms. So there's the sum of A and B. There's the difference of A and B. By the way, these are called conjugates. You're going to use this a lot in your next course. When we multiply conjugates, when we FOIL, the inner and outer terms cancel out. So we're left with just the difference of perfect squares. If you see you have the difference of perfect squares, that will later factor into its conjugates. But right now we're not factoring here. Okay, continuing. Negative exponents and scientific notation. Basically, we're saying if we have a to the negative n, and we can think of that as over 1, and there's also a 1 there that we don't write. We're going to leave this 1 up in the numerator. We're going to take this exponent, this negative exponent, cross the division bar, and as we do so, the sign of the exponent changes. So these two are equivalent, and that's what they're showing you here. Okay? Now there's a couple of other little techniques that we went over in great detail. For instance, if you had 3/4 to the negative 2, we could make this a positive exponent. But to do so, we just take the reciprocal of this. This becomes 4/3. And then when we simplify that, that's 16 over 9. Okay? Couple of little things. Again, we're not teaching it all here. We're just giving you a little review of what's going on. Now, when you do scientific notation, it's just converting a regular number in standard form, big numbers, small numbers, to a number between 1 and 10, and then to some power of 10. So this is a big number. We're moving the decimal over 4 places to make it a number between 1 and 10. That'll be a 1.2. And then it's going to be times 10 to, how many places do we move it over? 4. 4. 10 to the 4th. Here's a small number. We're going to move the decimal place over 6 places to make it 5.68 times 10. We moved it over 6 places. That made it a negative 6. So small numbers have negative exponents. Large numbers have positive exponents. Okay? There's a little summary. Now, when we divided polynomials in section 5.6, this is as far as we went, we said that if we're dividing a polynomial by a monomial, the key to this was to take each term in the numerator and, in a sense, divide it into parts, and then put that common denominator under each one. Okay? And notice what's happening here. You can then simplify each term so that it ends up with its simplest form. Now, do you notice something over here? Here is a variable in the denominator. Okay. What are they saying? They're calling it a polynomial, this expression. So, again, they sometimes are a little loose with that term, but we'll go along with it. Now, the other one that you're going to get is a sort of a challenge, is dividing a binomial into a polynomial. And there is a technique for that. And again, watch the video or the additional exercises if you need help on this. There is a protocol to it. I'll just review it quickly here. We're already up to 26 minutes. And you take, let's say, 10x squared divided by this 2x here. And that goes 5x times. So that's the number that goes up there. When you do this division, you put that number up there. That's what you're doing mentally. 2x goes into there how many times? Well, 5x. Then 2x times 5x gives you 10x squared. That's what you wanted. And then you go 3 times 5x is a positive 15x. Now, in elementary school, they said, what do you do now? Well, then you subtract. But here in our algebra course now, we have to say, how do we indicate subtraction? Well, as we said earlier, you change the sign. This used to be a positive, we're going to make it a negative. This was a positive, we're going to make it a negative. And then we add. There's where we get our negative 2x. Now, 2x goes into negative 2x a negative 1 times. So 2x times negative 1 gives me a negative 2x, exactly the same. And then 3 times negative 1 is a negative 3. But what do we do here? We subtract. So we have to make this negative a positive, this negative a positive, and then these cancel out, and we end up with a negative 4, which is our remainder over our divisor. And that's how you put it in MathLab. I'll clear it so you can see what they've done. Now, we don't do synthetic division in Math 1103, and we don't do one other topic, but I did do the PowerPoints if any of you want to watch that. So hopefully this will be useful as a sort of a review. I'll keep it short. It's already 29 minutes. Good luck on your final exam.